Hi everyone, my name is Tao Yang. I'm currently a PhD candidate student at the University of Utah. Today I will present a paper, Analysis of Multivariate Scoring Functions for Automatic Unbiased Learning to Rank. It's a joint work with Shikai, Fang, Shibo, Yulan, Wang, and Qingyao. First, let me introduce a little bit about the unbiased learning to rank. Its goal is to learn a ranking model from the click data. However, click data often by a source of relevance. It often suffers from propensity and noise. The existing solution to weight clicks to correct position bias. For example, here is an eyeball experiment. As we can see from this heat map, we put way more attention on top rank documents than the bottom one. To correct such position bias, we often make the following assumption. A click document means it's observed and it's also relevant. With this assumption, we can weight clicks to estimate the true relevance. However, as you can see from this formula, the propensity here is unknown, and there are many existing ways to estimate it, like we can do separate user study or do some online experiment. However, they will make it harder to be deployed in IR system or will hurt user experience. Thus, some research proposed automatic unbiased learning to rank to estimate the propensity. The advantage is that it can learn user-biased models with unbiased ranker, and it can be easily to be deployed in IR system. Another branch of our learning to rank study is multivariate scoring function. Due to the fact that it can model interaction and provide contextual information, when we do a ranking task, it already achieve state-of-the-art performance in many benchmarks. Here, we list the two state-of-the-art multivariate scoring function, the DLCM and the set rank. The DLCM is based on RN and set rank is based on self-attention. After this question, we have is can multivariate scoring function be adopted in automatic unbiased learning to rank and also show superior performance. Based on DLA framework, we conduct some theoretical analysis and found that computation invariance is necessary and sufficient condition for multivariate scoring function to be included in automatic unbiased learning to rank. Thus, we would expect set rank to perform better than DLCM, since set rank is permutation invariant and DLCM is permutation variant. Obviously, we conduct some experiments. We synthesize clicks with Yahoo and the Stella datasets, and we provide the initial rank list with the SVM rank. To better comparison the performance, we include the following baselines. The DLCM, since it's permutation variant one, there are three kinds of order. For example, the DLCM initial one, the order of it is just the same as the ranked list provided by the SVM rank. Besides the DLCM, we also include the DNN and DNN naive as the baseline. The DNN is the univariate scoring function, and the DNN naive is also univariate scoring function, but DNN naive don't adopt any debiasing techniques. Here is the performance the test performance on two datasets, and we can see that the DNN and the set rank performs better than DLCM, and the DNN naive, which demonstrates the effectiveness of debiasing, and also the effectiveness of permutation variant or invariant function. Besides that, we also see that the set rank performs better than the DNN, which clearly demonstrates the effectiveness of multivariate scoring function. The main contribution of our work is we analyze the state-of-the-art multivariate scoring function in automatic unbiased learning to rank, and found that permutation invariance is sufficient and necessary condition. And we empirically show the effectiveness of multivariate scoring function in automatic unbiased learning to rank. And we want to make the following acknowledgement that this work was supported in part by the School of Computing at the University of Utah. And I personally want to thank CIKM student travel grant support. Thanks.